Right, we have this calculus question in front of us, and we need to find the dy dx if f of x and y, a multivariable function, equals xy, all divided by x squared plus y squared. Find dy dx using implicit differentiation and partial differentiation. So, to actually solve this problem, we start as follows. So we let f of x and y be equal to 0. And surely this implies that xy divided by x squared plus y squared is equal to 0. So, which means, therefore, we have that the derivative with respect to x of xy divided by x squared plus y squared, this derivative equals 0. Right, so we're going to use the quotient rule to perform the derivative of this. So we first differentiate we first write down the denominator, like so, and then we differentiate the top. Derivative of x is 1, giving us only times y, which is y, and then now we have x times dy dx minus xy times the derivative of the bottom, which is 2x plus 2y dy dx. Right, and this here is nothing other than divided by the denominator squared. Okay, this is called the quotient rule of differentiation, and this equals 0. Right, and we have this, we cross multiply and expand. If we expand, we multiply y by this, getting exactly x squared y plus y cubed. Okay, just multiplying by y, multiplying this by that. X cubed dy dx plus xy squared dy dx minus 2. Okay, so minus 2 here. So it's minus 2x squared y minus 2, these 2 here, x y squared dy dx, which equals 0. Right, and then we just group like terms together, and we have dy dx into x y squared. Okay, let's start by the x cubed, is okay? Just writing things a little bit in order. So if you factor out dy dx, we will have x cubed here plus xy squared. So these two, and then the last one, which is minus twice xy squared equals, and then we transpose the rest of the terms. So we're going to transpose the x squared y, so it's going to become negative x squared y. And then we transpose this one here, but also transpose the y cubed, making it negative. And then we transpose this term here, making it plus 2x squared y, like so. Right, and then after having had this here written properly as we have written it out, we analyze this and we move to the we proceed to finish this off. So we have dy dx into x cubed plus xy squared minus twice xy squared. Right, we've already seen from the other side that you're going to have minus x squared y minus x squared y minus y cubed, okay, plus 2x squared y. Right, which means therefore we have dy dx. So what we then get out of this is we have 2x squared y minus x squared y, which is x squared y minus y cubed. Right, divided by, in the denominator, we divide by x cubed plus x y squared minus twice xy squared, like so. And this is x squared y minus y cubed divided by x cubed minus xy squared. Right, so hence we have that dy dx is x squared y minus y cubed all divided by x cubed minus xy squared. And this here is the dy dx that we've just got. And we have just got this derivative dy dx by using implicit differentiation. Right, hence this has been obtained by using implicit differentiation. By using implicit differentiation. Right, so we used implicit differentiation to get the result. And then now we're going to use, in particular, yes, we used implicit differentiation to get the result here. Okay, I want us to proceed and use another method right now. So using, right now, we shall use what we call partial differentiation. We shall use partial differentiation. Right now, we shall use partial differentiation. Right, so using partial differentiation, we have the function f of x and y, which equals xy divided by x squared plus y squared. Right, with that said, then we proceed to obtain the required result. So we shall use partial differentiation. So to use partial differentiation, we proceed as follows. So we begin by saying f subscript x is the same as the partial derivative of f with respect to x. Right, so if this is the case, using the partial derivative method, okay, we're going to use the quotient rule here because this is a quotient. So the quotient rule tells us that first we must find the derivative of the top with respect to x, which becomes only y. We multiply it by the denominator. Minus xy, we find the derivative of the bottom with respect to x. Divide everything by the square of the denominator, squared, which is yx cubed y cubed 2x squared y. You divide by the square of the denominator, like this. What is all this here, okay? So just watch out, this one here is a square. Because you multiply y and x squared, what you get is yx squared. So we have yx squared and minus 2x squared y. So this would become, or becomes y cubed minus x squared y divided by x squared plus y squared. Squared. Like that. Now, hence, f subscript x is actually the same as what? Is the same as y cubed minus x squared y divided by x squared plus y squared, and you divide by the square. Now, we also have, moreover, we need to get fy. So, moreover, fxy is xy. We divide by this. Moreover, that implies that we can be able to obtain f sub y, which is the partial derivative of f with respect to y. Okay, we'll differentiate first the top, which becomes only x. You multiply by the bottom minus. Right, and then now we have the top. The derivative of the bottom with respect to y is just going to become 2y. And then this is divided by x squared plus y squared. You square this. Now this is the cube of x, the square of y. The x and the square of y, which means you have x squared plus y squared, all squared like this. And this is the same as what? Is the same as x cubed minus xy squared plus y squared squared. Thus we have that f sub y is the same as x cubed minus xy squared divided by x squared plus y squared, and you square these. Right. Hence we obtain f sub x, y cubed minus x squared y plus y squared. So this is x cubed xy squared. You divide everything by x squared plus y squared. Hence, we obtain f sub x in that. So that what we desire the most, the dy dx by using partial differentiation, is minus f sub x, f sub y. Minus this. Which is x squared plus y squared. You square this. Okay, you divide by this, or it means you're multiplying by the reciprocal as follows. So you flip the f sub y around, and if you flip it, this is what you get. Like this. Now, this cancels this, giving us multiplied through by the negative, so you can write it as x squared y minus y cubed divided by x cubed minus xy squared. Thus, we can say dy dx is this minus y cubed, which is x cubed minus xy squared. Okay, now pay particular attention. So this is x squared y minus y cubed divided by x cubed minus xy squared. It's exactly the same as the other we got. The x squared y minus y cubed divided by x cubed minus xy squared is the same as this result here that we have just obtained. So this is the case, and we have got this by using partial differentiation. Partial differentiation. Okay, so thanks everybody for your time, and we really appreciate you watching, and goodbye to you.